Well, hey everyone, and welcome to our physics homework tutorial.
We hope you find this tutorial helpful in your study of physics, and if you do, please visit our website at www.physicsvodcast.com.
There you're going to find over 200 physics examples in every topic of physics. It's sure to help you get through that physics homework. We'll see you then. Hi everyone, here's your Sioux Falls physics teachers looking more at capacitors and circuits. And this problem is a series circuit with two capacitors of unequal capacitance. Again, our first step will be to draw a circuit diagram of the situation. First, we'll insert the battery, two lines of unequal length. For the capacitors, we need two pairs of lines of equal length. And again, notice that since they are in series, we need to have them one after the other. So we would follow the wire first to the first capacitor, which is 4 farads, then to the second capacitor, which is 6. The voltage of the battery is given as 12 volts. First thing in this situation that we will need to do is find the equivalent capacitance. And part of the reason that we need to do that is because we really don't know at this point how much of each of voltage is on each of those capacitors. So for a series, remember that our capacitance decreases, so we would use the equation with the inverses, and that would lead us to 4 plus 6 to the negative first. That means that the equivalent inverse is 0.42, giving us an equivalent capacitance of 2.4 farads. Now again, that's not really one of the final questions that is asked, but we will need that value to be able to find the rest of our answers. Once we have the equivalent capacitance, then we can go back to our equation of capacitance equals charge per volt and use this to analyze the entire circuit. So our equivalent capacitance was calculated at 2.4. Our charges are unknown, and the total voltage for the circuit is 12 volts. From that, we can find that the equivalent charge stored in the circuit is 28.8 coulombs. Now notice that even this is not actually one of the questions, but it asks to calculate the charge stored on each capacitor. Well, for a series circuit, remember that one of our statements is that the charge stored on the total circuit is the same as the individual charge amounts. So even though we have solved this using equivalent amounts for the entire circuit, it is also true to say that that is the charge stored on the first capacitor and the charge stored on the second capacitor. So both of these capacitors, even though they have different capacitance amounts, they must both have the same amount of charge. The last part then is to find the potential difference across each capacitor. And now that we know how much charge is on each, we can simply go back to our equation of capacitance equals charge over volts and plug in the numbers for the individual capacitors. So the first one has a capacitance of 4 farads. It is storing 28.8 coulombs, and that gives us a voltage value for the first capacitor of 7.2 volts. Secondly, we have capacitor 2, which is 6 farads. It also is storing 28.8 coulombs, and its voltage value then turns out to be 4.8 volts. So our individual amounts are 7.2 And for 0.8, we can double check that those are reasonable, because if added together, they do give us a total for 12 volts for the circuit. Also notice that the difference in voltages are necessary in order for us to be able to have the same amount of charge stored on two capacitors with different values for capacitance. So in other words, our first capacitor here has a pretty low capacitance value. So in order for it to have the same amount of charge as this capacitor, we need more volts on the first capacitor and fewer volts on the second.